Okay, my intent here is that, certainly I'm giving you, code. It would be nice if you could type it in. For example, reset, X is a variable, integrate. It wants to find the antiderivative of this thing over here. Relatively simple. All right, relatively simple. But what they point out here is it's integrate, antiderivative, something to do with the fundamental theorem of algebra. Look at it. Make sure you understand there's a relationship here between this code here and what comes before it. All right. So look it over. And certainly I'm looking at all these lines of code, and I'm going to say it looks somewhat familiar to me. For example, this one wants me to integrate, which is find the antiderivative of this thing over here with respect to X between 0 and 1. All right. This one looks like that bug problem we had. And I think we did that one too. Now, of course, I'm going to say over here, I think I have something new that I have not seen before. All right. So what I want to do is I just want to play around with it. And, I want to go back to Sage. And let me just see if I can do that. Let me clear. Let me reset. And let me define the variable J. All right. So J is a variable, and that variable is J. All right, let's see if we can understand what this one says. Sum 0.1. Well, you know what? I notice I use V over there, so I got to define V now. And what's V? Well, V is a function of T. So I got to define T, right? So T is a variable. And V is a function of T. And that is, and we'll look back over there and see if we can figure this out. And it can't hurt to look at this and go back and see how it applies to the problem set that we just did. So this is 1 divided by 1 plus T. All right, let's go back to that sum. And then we'll go back in the notes and look for that bug problem. And it's 0.1 star V 0 plus 0.1 star J, or now again, for students that study computer science, I think you probably know something about a for loop. And this says for J in 1 to 10. I got a number there. I'm going to scroll back in the notes though. And this is the problem. You want to go back and look. How does this apply and how can you reuse it? Right? How does it apply and how can you reuse it? All right. And I'll certainly go through that with you, but I want to go back to that bug problem we did. I know for a lot of students, it's tough to go backwards. Yeah, a lot of scrolling here, huh? Well, I think this is the bug problem. And just to remind you, it was, V2 is a function 1 over 1 plus T. That's right over here. Right? I think you remember that. And so it's about estimating areas. I want to see if I got this sum down over here. And someone says, I don't even know what you mean by that. Did we do that? We did. All right. So I'm going to point out, I don't think it's this one here, is it? Let me keep scrolling. I don't think it's this one here either. I'm just looking at the number. Look at the 66. You get the idea? Again, I want to see how I can reuse the problem. Maybe it's this one. Right? I'm looking at that number, 0.668. They got this one over here. By the way, I want to see if I can get the number they got. All right. So I'm going to rewrite that code. Sum. Now, remember in the past, we said if you use decimals, it'll give you decimals. I'm not going to use decimals now. What's 0.1? It's 1 divided by 10 star V 0 plus 1 divided by 10 star j, just recopying, for j in 1 dot dot 10. And let's see, do we get the same number they got? Well, let's see, 155, 685, 007 is the top number, bottom number, 232, 792. Wow, we got it. Now let's say you want to approximate that. What would you do? Dot n. Let's see if it does it. And now I got it. All right. So I'm going to say that it's a sum problem, isn't it? So what is this thing over here? It's a sum of this thing over here, right? This is the same thing we got over here from 1 to 10. So the deal about this over here is, you could say, I wonder if I could reuse this code to do other problems. And I want to look at this one over here and see, could I reuse that to do this problem here? I'm going to try. Who knows? Maybe I'll get it wrong. Sum. Well, that's going to be 5 over 100, right? So 5 divided by 100 times V 0 plus, now I know they're using an I there. I'm using a J. So what's going to be? Well, 0.05 is 5 over 100 still. 5 divided by 100 star J, right? For J in, and we're going from 0 to 19 now, aren't we? I'm not going to put the end down. Let's see if I get that number they have there. Let's see if we got it. It's hard. It's tough to read. I'm not saying it is easy, but I'm starting to see it. Top number, bottom number. I want to approximate that. So dot n. It should be 0.706. Yep. Now someone says you got 705 there. Well, look at the number to the right of 5. It's 8. If you round it out, it would be 0.706. So here's the deal. You learned something. What'd you learn? How to take a sum. Where were some introduced, though? Sums were introduced in Math 120. And you had all kinds of spiffy ways of manipulating Math 120. All right. But, I'm on a roll. Let's see if we can do this one over here. All right. Sum. Right. This one goes to 20 now, right? Of 1 to 20. So it almost looks like the same problem, doesn't it? But I want to do not 0 to 19. I want to do 1 dot dot 20. Look at the number. Looks like they're pretty good. I'm going to approximate that. Yep. And the same thing, 0.681. Again, if you round it properly. All right. You've learned something. What'd you learn? How to take a sum. Okay. Over here, this is the Mathematica code. Don't worry about it. No longer have Mathematica at Essex County College. Why is that? I was the only one using it. Essex County College got sick and tired of paying for it. They said the students aren't using it. Why aren't the students using it? I said the students weren't interested in that. Why we weren't using it? And I was interested in using it though, but no one else was, including the faculty. No one used it. All right. They got rid of it. All right. They're not going to just pay that kind of money. They're paying thousands and thousands of dollars for me to use that software. But anyway, you got Sage now. And Sage, since Sage is good, you can do all these computations, by the way. All these computations, by the way, can be done in Sage. Please, you need to learn how to write things down with paper and pencil first. Do simple computations, paper and pencil first, before you go to the use of a computer. All right. But the bottom line, a lot of this stuff is formulating a problem using paper and pencil and eventually going to a machine to do it. A lot of these things are very simple numerical problems, though. We're not trying to stress you out. Granted, I realize some of those initial problems did require me to use a calculator to do the sums, and that's something you may want to consider. All right. So there's a lot of problems there we thought about. I want you to think through, yada, yada, yada. At the end of this thing, just like all the other sections, we eventually get to Sage. Thank you for paying attention.